Well, hello everyone, and welcome back to Prep 8. So here we have groups of multiple choice questions that are all about the setup when you have a prompt and you're doing a hypothesis test. So I'm going to go through a couple of these blocks and then let you deal with the rest of them. All right, so the first one. An advertising company has created two versions of a commercial. They want to figure out which commercial is more effective. They have a group of participants watch version 1 and another group watches version 2. After participants watch the commercial, they rate how much they want to purchase the product on a 10-point scale. So what's the direction of the test? Right? Now, because they say they want to figure out which commercial is more effective, it means that they don't know. And if you don't know up front, then you're always dealing with a two-tail test when you don't even have a suspicion of which one's better than which. So that's two-tail. What's the alternative hypothesis in words? Well, the alternative hypothesis, actually it's easier to do the null hypothesis first. I'm going to skip down to that. Here's the null hypothesis in words, which is that there is not a significant difference in effectiveness when comparing the two versions of the commercial. So the null hypothesis will always be the one that says no significant difference. Then the alternative hypothesis is, well, yeah, there is a significant difference, so that's why that's going to be answer B. Now what about symbols? What's the null hypothesis in symbols? In symbols, the null hypothesis will always be the hypothesis that's the equal sign, so that's D. And the alternative hypothesis will always be the hypothesis that has the not equal sign. Now, when I say always, what I mean is always on a two-tail test. It's going to be different if it's a one-tail test. But for two-tail test, null will always be equal, alternative will always be not equal. So not equal is C. And we're done with this answer block. All right, so let's look over here where we actually are looking at a one-tail test, a directional test. This is when we actually have an inkling that one is bigger than the other, better than the other, greater than the other, something like that. Okay, so a department store knows that their average customer spends $96 with a standard deviation of $29 average spend. A study was conducted to determine if people who pay for store purchases with a credit card spend more than the average customer. An analyst took a sample of customers who paid with a credit card. Okay, so let's find the null. It's going to be the easiest place to start. So what's the null hypothesis in words? That's all the way down here. And the null hypothesis in words is that there is no significant difference in the spend between credit card users and the other ones. And then let's go for the alternative in words. So the alternative hypothesis is that people who pay with credit cards spend significantly more on average, right? It's a more. So that's going to be C. So it's directional. So here's the key, right? When you're dealing with a one-tail test, the null will still be the same. It's always going to be not equal. So same as a two-tail test, one-tail test, null is always equal. Null is always equal, okay? Just like it was on a two-tail test. The null is always equal, meaning there's no difference, right? You know, that none of this intervention is going to make any difference at all. And the alternative, though, on a two-tail test, the alternative is simply not equal since we don't know the direction. But the alternative in a one-tail test is always going to be directional because we do know the direction that we want. Okay, so let's find null hypothesis in symbols. I'll come down here. So as I said before, it's going to be straight up that they're equal. And the alternative hypothesis in symbols is going to be that it's more. All right. So now there's two versions of more. There's C, which is credit card greater than other customers, credit card customers greater than other customers. And then there's E, which is credit card customers greater than or equal to other customers. Now, it can't be E because greater than or equal to includes equal to, but equal to is the null hypothesis. So we can't allow that as part of the alternative hypothesis. So that forces us to C. And then finally, what's the direction of this test? This test is more, right? The keyword more means greater than, bigger than. So it's to the right because basically it's going to be a positive number, an increase. And we get that answer block as well. So I've done 2 of these. This one was for a two-tail test. And in fact, I think this whole column on the left is two-tail tests. So they're almost going to be identical all the way down. On this side, though, this side has more of the one-tail tests. And your key is you have to figure out, is it greater than or less than, right? So, for example, they are wondering if a new software package will provide shorter. Shorter sounds a lot like less than, right? Down here, university wants to have the earnings potential increases earning potential. Increases sounds like greater than, right? Right-hand test. So left. So less than would be left tail test. Increase sounds like one tail to the right as opposed to one tail to the left for that one. All right, here, department store, down the stars. If a customer's shop are younger, younger would mean less than, right? Or one tail left. And that does it for these questions, which are based upon direction. And the reason I said that the other group, I think, is all non-directional, because let's read. Is there a gender difference, right? And we're saying difference, we're not saying which direction. So that's non-directional. If Buffalo and Boston residents differ, right? Differ is non-directional. We don't know who's ahead. Differences in checking account balances. Okay, it's non-directional. We don't know who's ahead. And so that's why I'm pretty confident that all of these are two-tail tests, non-directional, on that left-hand column. So this is super important stuff, and you're actually going to see after you've done these, when you get to the next tab, or the next 3 tabs, that all of this comes into play when you're setting up the problem. And of course, setting up the problem correctly is the key to solving it. 'Cause if you set it up incorrectly, you're solving the wrong problem, and so all your answers will be incorrect. We'll see you in the next video.